My name is Rob Bissett. I'm head of product strategy for a company called Six Fusion. We're in the business of trying to quantify in a standardized way infrastructure and infrastructure consumption so that we can overlay an economic consumption-based model on computing. The idea behind doing that gets away from arguments about IP stacks and IP addressing, but gets into quantification of the business case. Why should we be on-premise? Why should we be off-premise? And as you start to look at some of the concepts that will be discussed today, those decisions become even more complex when you start about fragmenting and pushing towards the edge. So we basically have built a standardized unit of measurement, a SaaS platform that allows you to quantify consumption. Right? Look at your infrastructures as generators. How much do I have? How much am I using? What's my marginal cost per unit? And then start to do economic analysis on top of that. We partnered recently with the Chicago Mercantile Exchange with the notion of actually developing markets around this in the same way that you use these economic concepts in electricity and then markets developed around electricity to drive those concepts. We're trying to do the same thing with computing. So we bring a very business ROI-focused methodology that's vendor impartial to these technical conversations. That's what we do. 10 seconds. I could probably go for an hour. I could probably go for an hour, but it'd get boring real quick.
Hi, I'm Hosain. As I mentioned earlier, we are I'm from Aeris Communications. We are an M2M IoT services provider, all the way from communications, transport of data, through to cloud solutions and data analytics. Everything in between. Any customers come in at various points. We provide enterprise-level M2M and IoT data services. I have a slide on our company, just one slide on our company later on during my presentation, so I'll go slightly more in depth in there.
Hi, I'm Nicola. As I mentioned to you earlier, we provide mesh Wi-Fi and edge computing and distributed computing. We provide hardware and software technology both, and because we produce our hardware directly in Italy. And our idea is to distribute the calculation capacity all over the network in order to optimize the cloud with our cloud provider partner, and I can show to you some slides with my presentation after that.
Thanks. Yeah, Ken Hosac with CradlePoint, and I appreciate the opportunity to be here. CradlePoint provides networking solutions that are really focused at distributed enterprise, and specifically customer-facing distributed enterprises. And one thing I appreciate about this conference is, this is not a sales pitch conference. This is an exchange of ideas, and I appreciate that companies have been open. You can see from the Cisco presentation this morning, they're sharing a lot of their vision. I really appreciate that. And in the spirit of that, I'm just going to describe our journey, what our customers have been asking for, how they're migrating from kind of the old legacy models to some of these newer models.
Okay. I have your slides up.
Hi, folks. I'm going to talk a little bit about our company first. Just one slide, get into some of the topics. I love the presentation from Charles, so I'll skip over quickly some of my thoughts because I think they duplicate his. Either that means we're both right or we're both wrong. Hopefully, we're both right about some of the things that we're going to talk about. About Aeris, who we are. We've been in the business of providing M2M and IoT services for more than 18 years at this point. It'll be 19 back in January. One of the founders. We've been doing this for a long time before the phrases M2M and IoT even existed. Solution is a complete platform, all the way from the connectivity at the bottom, cellular connectivity, that has been our focus right from day one, all the way up through cloud delivery and data analytics. Been very reliable, operating worldwide, 190 countries, currently processing well over 250 million M2M messages a day. And that's growing dramatically. That number may actually be out of date by a lot. Upper right, you see the markets we operate in, ranging from point of sale, utilities, et cetera, providing complete connectivity, single point of contact, business and technical, through the 500 plus carriers that we work with. Cellular, so we do GSM, CDMA, and LTE. Obviously, at this point, there aren't any significant LTE deployments for M2M and IoT yet, but they're in development and will happen soon. And then in the bottom right, you guys will get access to these slides. I assume that it'll be put up somewhere that you can take a look at what we're up to. Connectivity on the bottom all the way up through the cloud, our own billing system, so we can provide some custom billing solutions for companies that need it. Now, I like to keep things simple, so I'm going to give you sort of a simple view of my perspective on what the Internet of Things is all about. You have sensors and devices and things that are out there. I put things in quotes because it could represent all kinds of applications and devices, et cetera. Going through connectivity and transport using some kind of protocol, whether it's a protocol that is encoding through APIs or whatever, there is some transport all the way to the systems and processes and people who need that data, who need to be able to make actionable business decisions based on that data. Obviously, this transport and connectivity is bidirectional. The information flows both ways. You get messaging from the units and control going back, or configuration and information going back. Okay, so what's happening in IoT? There's been an explosion of new IoT applications, and they're connected through cloud solutions in general, starting to do that quite a bit. And there's been a demand for efficient access to that data. Efficient is the word that's important, and that's where I'm going to focus on a little bit later in my quick few slides over here. People recognize that information has value, and more importantly, data mashups have greater value, more than just the sum of the individual bits there. So the thinking that tends to pervade the industry today, or at least the customers are looking at this stuff today, is just gather everything and send it up to the cloud. Gather as much data as possible. That's a fallacy, and that's an important problem that we need to deal with. So this explosion is bringing some new challenges. I borrowed from the Cisco VNI. I sourced it, so you can see that it's from Cisco. But the staggering growth that's occurring in the industry today, there's explosive growth occurring. Scaling is an issue. Security for the content, security for the transmission chain is an issue. The storage, efficient analysis of that data so you can do something with that data rather than just gather haystacks everywhere. Multiple transport technologies are being used, connectivity management becomes an issue, and I could go on and on. This is just a smattering of things that I picked. I do believe that the two top bullets, scaling and security, are the absolute barriers that we have to worry about in the M2M and IoT space today, and we have to address them, period. The first time a security event takes place that causes significant harm in the IoT space, we'll be hurt. And if we don't take into account the issues that are necessary for making sure that scaling occurs in an efficient way, then that'll also be a problem for the growth. Those numbers will not materialize, and that's what we got to be worrying about. As Charles mentioned, the numbers and predictions are staggering. I just took a handful of things that I could find on the network information, all the way back to 4 years ago from 2010, IBM saying that there will be a world with 1 trillion connected devices within a few more years. And the main point of this slide is that the numbers are all in the billions and higher. And the other main point, which is kind of interesting, is that in the 4 years, the hype hasn't gone away yet. It's still a scaling issue. People believe there will be billions of devices by the end of this decade into the next decade that we need to worry about, that we need to do something with. That infographic from Intel, I think, is pretty telling. The applications and usage of this space is growing dramatically. Now, big data says something interesting. We don't know what we want to look at, so transmit everything, store everything, and search those haystacks. I disagree. I think there's some big issues over there. Charles went into more detail. I'm just summarizing a little bit. Finding that timely, actionable information, that data that makes business relevance, can be very expensive if you're not careful, particularly if you shove everything into the cloud and now you're searching and filtering all of that data in the cloud. The cost of transport is important. In the wireless world today, everything is metered. It's going to happen in the internet world if you're not careful in the near future. Cost of transport is going to go up. The storage of that information, the analytics associated with processing that data is going to be just a big deal. So distributed filtering of that information is absolutely vital. Let me just take one of those predictions, because I'm an engineering geek numbering kind of guy, so I'll give you what do the numbers mean. Let's take one of those predictions. The most famous one is from the Ericsson CEO, about 50 billion devices. So what's the impact? Let's look at today. Today, on average, cellular, and I'm going to focus on cellular because that's our forte, that's what we do. M2M devices send on average about 2 megabytes a month. Not a lot of data. Collectively, in the United States alone, those 15 million cellular devices, which represents only 8% of all the M2M devices in the US today, are sending 30 terabytes a month. That's a lot of data. If you believe that 50 billion number, that at 5% cellular, That's 2.5 billion cellular devices. If you assume a modest growth in the average from 2 to 4 megabytes per month, we're talking about 10 million terabytes a month of data. If you take all of the devices, that's a number that's 20 times too small. It's closer to 200 million terabytes of data per month. That's a lot of data to shove through the transport pipes, the storage, the analytics engines that you have in the cloud. Just will cause problems, period, anywhere. So the transmissions, even if you assume conservative estimates, total data haystacks are enormous. And sticking your head in that haystack, looking for that data, is going to be a problem. Okay. Upper right, by the way, is Monet. Demands filtering at the edge. You have to do it. You have to push that filtering out further away from the cloud as far as you can reasonably take it. Fog computing is one of those approaches. Now, I happen to believe that 50 billion sensors means those sensor costs need to be low. They're going to be very cheap, very inexpensive, very low power, very low computational power, and therefore trying to put filtering at the sensors or completely at the edge is going to be tough. So one logical place to put it is in the gateways. Now, gateways to me aren't just a set-top box in a house. It could be a building gateway. It could be a pole gateway. It could be further up the chain, as again in Charles's presentation. There are many layers. But I'm going to use a collective term gateway, meaning someplace where I can connect those sensors and devices. I can aggregate the hybrid sources of my data and then do a WAN transport, whether it's cellular, whether it's wireline, whether it's fiber, whether it's satellite, whatever makes sense for that data to be sent. From that gateway point onwards, that's the place where you can imply intelligence. Important point, your filters will change, and therefore the gateways must be programmable. You've got to make sure that if you decide that some new data needs to be provided, or you've got a new source of information coming in, that you can program that gateway to get that data and information filtered properly. Agents, software in the gateways, maybe the devices if they're big enough and powerful enough to accommodate it, but usually in the gateways. And I also believe that, just like Charles mentioned, the gateway is a great spot in the chain for your best security practices to be applied. That's where, if you have a compromised device, if you have a compromised sensor, if you have a bunch of compromised sensors, you can avoid the impact of that compromised data, whether it's information or something worse, getting all the way back into the cloud and causing havoc elsewhere. Okay, so let me give you some final thoughts. If we're going to succeed at this scaling issue, I didn't talk about the other parts. If we're going to succeed here, we need to have 4 things. Cooperation. That's where organizations like the International M2M Council, the Industrial Internet Consortium, and others are taking a stance on how do we get cooperation between ideas and applications and innovation to happen. You need standards. There's ETSI, there's TIA, there's 1M2M. Those are the folks who are focusing on providing standards for transport, for security, et cetera. There are APIs. There are two obvious consortiums that have taken shape over here. There's the All-Seen Alliance, the Open Internet Consortium. Different players in both, and there will be a shakeout. There may be some interoperation needs that will happen in the future. And obviously, there's education. You have to provide education to people to make sure if you're going to succeed at getting those 50 billion or whatever the right number is of devices out there, that information and education for all of us in the industry who are working on it, as well as the people who need to get that education, find out about what's necessary to make all of this happen. So that's pretty much it. My slides will have the information for contact. If you guys have additional questions, this is just a small subset of things that we worry about and are working on to solve in the future.
By the way, one more thing. C and I actually had a webinar on fog computing that's up on the M2M Evolution site. You can go back and look at that, and it's also up on their site as well. So I recommend taking a look at that. Are there questions? Joanna's coming to you, young man.
Why do you feel that it has to be at the edge and not on the sensor? Couldn't we have, couldn't we have thresholding on the sensors to limit the amount of data that comes off of them? That'd be the first step.
Absolutely. I think that the filtering could be hierarchical as well. Some filtering at the sensors, some of the gateway onwards. Absolutely. I'm just thinking that with 50 billion sensors and devices, those sensors have to be really low cost. So they're not going to be very powerful filtering at that position, at that point. But definitely, it could be there.
A question about in your mind, is there a distinction between filtering and full-blown analytics? So, for example, if the sensor is an ultra-high definition camera, a filter might drop 4/5 of the frame and only send so it's not really doing much intelligence. Whereby analytics would say, I see people moving southwest and they're driving a pickup truck. Do you consider analytics, a superset of filtering, and is that part of your scope?
Yes, it is, definitely. I think that the gateways will absolutely need to have decision-making, and to do decision-making, you've got to do analytics at that point. Now, collectively, how much information that gateway sees to be able to make intelligent decisions will depend on the application and what's coming in. But yes, I absolutely agree that when I use the word filtering at the edge, it's sort of not just the pure data, but the actions taken associated with that data.
By the way, don't feel obligated to just let him answer those questions.
Yes.
Okay? Go ahead, Evan.
One of the things that encouraged me to come here is when I heard Cisco doing it, and I immediately realized that it's got to do with routers. So you mentioned gateway, which is one of the best solutions that I was brainstorming with others. But you have data, a bunch of data that can be blocked inside. Example, you have Wi-Fi router at home. Instead of sending all those data in the cloud, you might as well keep them in-house with the storage device and censor them.
Yes, but I think it's so early. I don't think there are any gateways out there that are implementing the kinds of things that we're talking about, except in an experimental way. I don't see any production solutions yet. At least I haven't looked. I don't know if other people have any thoughts on that one.
I think Ken might have some thoughts, but we'll wait.
Great.
But he brought up Wi-Fi, which is a great segue to Nicola, so I'm going to let Nicola take over.
Okay. Thank you very much. And today, I don't want to talk to you about this market because I think that you know this market better than me and the opportunities that will come from this market. But I want to talk to you about our practical approach on the fog computing application and how we can solve the problem that will come from this growth, this incredible growth of application of connected item or connected things. And why next? We started in 2008 with our controllerless technology to create a huge Wi-Fi mesh network completely independent from a controller. And in 2011, we have developed our first wireless mesh sensor technology. This is our first effort in the IoT space. And in 2013, we started to produce the hardware by ourselves because we need the control of the hardware in order to transform a normal access point in a hub of different sensor protocol in order to add GPIO bus expansion to our IP. And we were not able to manage this with Chinese or Taiwan producer. And for this reason, we moved the production in our plant. And finally, now we are moving on the industrial IoT because we are focalized on the industrial IoT with our wise mesh patented technology for the distribution of processing at the edge. And this is an example of our approach. Our approach on, this is a benchmark between the centralized versus the distributed networking. In the first case, the sensor produced the data, very similar on the second case. And in the first case, the data is sent to the cloud. And this is with a centralized data processing. In our case, the data is analyzed very close to the sensor with this distributed technology, with this distributed capability. And in the first case, the cloud analyzed the data that received. And in this case, you don't have predictable time of reaction because there are a lot of maybe problem in the backhauling, for example. In the distributed example, the network generates directly, locally, the action. And in this case, you can have a fast and predictable reaction to the event. Okay. For this reason, we want to move the data analysis capability very close to the sensor, very close to the machinery, and then send to the cloud the valuable data, only the valuable data, in order to optimize the data streaming on the network. And another example, we are completely cloud agnostic. In this case, we work with our partner, Plat1, and in this case, for example, we can create with our AP, with our router, a LAN, obviously, on IP level, but at the same time, we can aggregate different protocol with, for example, the bus protocol. We can integrate in the mesh. We can add very easily the camera, the machinery, but in particular, I think that it's important to maybe add data capacity calculation with the Fog microserver, for example, very close to the machine or to the endpoint that you need, where you need more data capacity, and so on with the star architecture, Bluetooth, Zigbee, all in the same networking in order to optimize the management also of the different nodes. This is an example, very easy example of temperature monitoring scenario. In this case, we need to monitor the temperature and the fire detecting in industrial plant. You can deploy the node. Our WISE mesh starts the mesh network in a self-configuration routine and start the sensors at the same time and begin the distributed sampling, okay, all over the plant. But, for example, in order to optimize the conception and the networking routing, the sensor without relevant data are turned off directly locally on the network without the help of the cloud. And at the same time, the routers that are not useful for the networking are turned in standby in order to optimize the networking and the routing and the conception. In this way, we can preserve the information quality. We can optimize the power consumption locally, and third, but last but not least, we can better manage the security of the network. In case a node fails, the routing is automatically recalculated and an alert is sent. And if you need to change the requirement of the monitoring, for example, you can easily add node sensor to the plant in order to check different data. In case of unexpected condition, you can, such as fire in the plant, the sensor can automatically detect the problem, and the network locally can add they can turn on adding sensor in order to double check the event in the plant. Finally, the main benefits of this approach to the fog computing is a less latency thanks to the integrated distributed processing on the wireless network, more security thanks to the opportunity to manage the data tagging directly to the network, and the more scalability because we can add in a very easy way the network resources, the machine, and other resources on the network. Thank you very much.
Okay, go ahead. Ken, set up. Nicole will come on down. Questions for Nicole? Nicola De Carne, D-E-C-A-R.
Yeah, sorry, there is not, but I'm very happy if you can discuss deeply on our desk on your back. Thank you very much.
So just out of curiosity,
Thanks, Carl. Again, I'm Ken Hosac with CradlePoint, and one of the things I've learned, I've spoken with several of these gentlemen at some of the M2M Evolution conferences and the fog computing, is a lot of these concepts are really applicable to a lot of different industries, and so it's very hard to get into specifics without really kind of understanding the frame of reference. And so from a CradlePoint standpoint, just for contextual purposes, our customer is, they're the smaller footprint distributed enterprises, and specifically customer-facing distributed enterprises. So these are the companies that are essentially selling you products or selling you services, processing credit cards, trying to deal with, it's a small location, so no local IT folks, trying to embrace Wi-Fi, not just for the customers, the smartphones and the tablets, but also employees and increasingly devices that are being attached to those locations. And they're really struggling with, as they've moved all their applications to the cloud, the resiliency of that network connection is critical to that, because if you have cloud-based applications, your Achilles heel is the network connection. If the network goes down, you can't process it. Where CradlePoint got our start several years ago in enterprise was Hurricane Katrina. And after Hurricane Katrina, State Farm realized that they couldn't access their cloud-based applications. So customers, and that's when the customers needed it the most. I want to process look up my policy, process my claim. And State Farm had a perfectly good Cisco router in their branch offices that was only using one of the WAN ports. And so we got our start by developing a failover solution that converted 3G and 4G to Ethernet, and we put it in the back of that Cisco router. We shipped 18,000 of those, and State Farm had a very resilient network. And it's not just for natural disasters, but a lot of our customers are really trying to embrace these lower cost networks. Instead of paying $500,000 on a T1 line, trying to use DSL cable, some of those networks that frankly aren't necessarily as reliable, or at least there's a perception they're not. I think the reality is they actually are. But if you consider that some of those networks are about 99% available, if you combine that with a completely different network that's not buried in the same ditch like LTE, then, and you look at the downtime and do the math, you can start to approach 4 nines availability on your network connection. And at some of these locations, that's pretty impressive, especially at the cost that you can get. So in terms of what's driving our business, or at least what the customers are asking, I'm going to really put my presentation in the theme of what customers are asking us to do. There are 2 types of applications, or 2 categories of applications of what's driving their networking needs, their compute needs, their storage. And really, it's that classic make money, save money side. On the make money side, it's all about customer engagement. It's digital signage, customer Wi-Fi. Analytics is becoming increasingly important. What are my customers doing? For those of you that are tracking kind of the Google rollout at Starbucks, they're using cameras, video cameras to do analytics. What's the dwell time as I stand in front of this, this display unit, or they're turning it behind the counter and doing barista analytics. That's a lot of data. And right now, one of the reasons they're using CradlePoint is they want a high bandwidth connection up into the cloud. It's not sustainable as you keep applying that to all these different needs, and that's why this, this conference is a really important one. On the save money side, security is a big issue for our customers. One of the things that has really driven our business recently is this notion of parallel networking. And after the Target breach, a lot of our customers started realizing trying to use network segmentation to secure your networks is a impossible task. The hackers can get in there. They know how to scan for misconfiguration or errors. They know how to do pivot attacks. Once they do the pivot attacks, they can get that malware on the devices that they need to get to. And that's how you get these Target, Home Depot, PF Chang type attacks where they're able to do that. What's really been driving our business recently is this notion of parallel networks, where enterprises are basically saying, I give up. I cannot secure my monolithic network. And they're breaking it up into individual application-specific networks that use completely separate network access. And where I'm going with that is that's where a lot of the concepts we're talking about are really critical. Because if you have a core network, you can spend the $150,000 on a big firewall and VPN concentrator and a lot of that hard work. But when you break it up into individual networks, you need a way to get that same security, that same functionality from that big expensive hardware for just a simple application. Walmart, the hunting and fishing license terminal. It's tied to the state government system in every state. Walmart doesn't trust the state governments to secure that as a point of ingress to their network. So they create a completely separate network using 4G LTE so they can get it off their network. If you walk into a Walmart today, you'll find anywhere from 15 to 25 of these separate networks. Everything from the Red Box, the Coinstar, the greeting card. Jackson Hewitt has a tax station they bring in there during the season. You got the optometrists, and then Walmart themselves are carving them up. So again, that's the context for what I'm going to talk about with some of the cloud computing concepts. So from our standpoint, we find ourselves kind of bridging these two worlds. It's this traditional enterprise networking world where it's all about private networks, it's all about security, UTM, IPS, IDS, for enterprise, traditional enterprise devices. But we are also heavily in this M2M IoT space. And it's just, these are things, again, we focus on the customer-facing versions of these M2M devices. It's things like digital signage, kiosks, the sensors that you'd find at the front door of a 7-Eleven or the fuel tank. We don't look at the 50 billion devices. I know in the US there are 4.7 million, which is million, not billion, 4.7 million of these customer-facing distributed enterprises that are really trying to embrace these new technologies and sensors. And that's what we listen to. I've been at big companies, I've been at small companies, and I can tell you the way you can differentiate them is, I use this analogy of the high beam and the low beam. The low beam versus the high beam in a big company tends to be 2 years versus 5 years. In a small company, smaller company, the low beam tends to be about 6 months, and the high beam, if you're lucky, is about 2 years, and sometimes it's less than that. From where we're at, we're just talking to customers and we're letting them kind of tell us what their needs are. And we celebrated the shipment of our 1 millionth router, so it's not a billion routers, but it's, we've been getting very, very good input from these customers who are using these in these alternate networks. In terms of the migration from the physical to virtual world, I just kind of have the past, present, future. I would say right now, the past, everything was hardware. And you look at the kind of the on-prem equipment, the network equipment and devices, as well as the centralized application, centralized network equipment. I think where I'd say today is everything in the centralized application is virtualized. There's just no question of that. You would never, even if it's your own data center, but it's virtualized. In the network equipment, I'd say that's where there's a big shift right now on the core networking equipment. I think for a lot of companies, the management is virtualized, but a lot of the heavy-duty hardware is still, heavy-duty functions like firewall, UTM are still hardware. And obviously, every company on the planet is looking at their virtualized strategy for that. And then on the devices, what you'll see is kind of in the past was just your legacy enterprise equipment, your PCs and laptops. Printers, migrating into where we're at today with this, how do you deal with smartphones and tablets for customer engagement, customer analytics, and then going in the future, adding all these IoT devices. And what we're really getting a lot of feedback right now is this combination and this I think this is what we saw in the earlier presentation around fog computing, but it's how do you leverage the on-prem network equipment with the adjacent cloud, and it's not, again, not your virtual servers, but that close-up stuff. And if I look at that a little bit more detail, and this is the last slide, is what we're seeing is that people want to treat the functions that they have on the store. They want to reduce the cost. And my favorite example is iPhone and Siri for how you can use essentially virtual assist. If you put the hardware required to do voice recognition on this Siri, on this iPhone, this would be a $6,000 device. The reason that the voice recognition works so well is that pulls it up to the cloud. They use supercomputing virtual resources to translate it to text, and it sends the text back down to the phone. And as a result, they're able to get much better functionality, much more powerful functionality without driving up the cost of this device. And in the world of networking, you can apply that to security as well. If you think about IPS, IDS, UTM, what you want to be able to do, you can't push it all up into the cloud because that's going to require sending every bit of data that you generate at these locations up to the cloud to get scrubbed. You need some flexibility of which they need to be application specific, or in some cases scenario specific. You need to know what to push up to the cloud, what do you do locally, and what do you just not worry about at all. I would say the areas that we're working on, again, we're a network solution provider that consists of hardware and cloud. All of the routers that were released this year, we've added a ton of compute and storage. When I say a ton, I mean it's all relative, much more than we had before. Because customers are basically saying, I need the ability to put my applications on your router to do local processing. A lot of these guys have been doing it by just having a Linux box that they put at their distributed locations, and it's just, they want to consolidate that. I'll give you a very simple example. We work with a company that does inventory at Home Depot. It's a third-party company, so they come in at night with 200 people and 200 handsets, and they do the physical inventory. Home Depot does not want to share their network with them, so they have to bring their own network. And they came to us a couple years ago and said, Ken, I just need a place on your router where I can put a simple database with the prices. Because I have these 200 people with the handhelds, I don't want all that traffic going up to the cloud, coming back just to look up the same thing. I just want to look up the price. And so as a result of this feedback, we've added the compute, added the storage, and we've implemented a sandbox in our routers. So we have APIs to the routers that can be used, but we've implemented a sandbox where customers can essentially develop their own applications and put that in the router. We've also done the same thing on our cloud management side, expanded that platform so it's not just management, but it's applications and services. We have a sandbox where people can put applications in the cloud to work in conjunction with those applications they put in their devices. But if they already have cloud solutions, they can do cloud-to-cloud APIs, et cetera. I think one of the keys, we talk about security, and I think there will be some presentations later today about security, but we have really leveraged the cloud because once you break up that monolithic network into these parallel networks, again, you can't go buy a $50,000 VPN concentrator or a $100,000 firewall, but you still need that capability. And so we've developed cloud-based VPN concentrators. We've developed cloud-based UTM solutions so that you can connect those very quickly for the smallest application and not burden that application with the cost of all that hardware. So I guess in general, I'm not looking terribly far out. These are, as we talk to our customers and what they're asking for, these are the things that we're implementing. And again, I'm sharing this in the spirit of, this is not a conference where you find a lot of end customers that are asking about buying solutions. This is part of the ecosystem. And as a lot of us have been through the development of many of these ecosystems, they really form by the ideas of a healthy ecosystem consists of multiple companies sharing ideas, looking for best practices, looking for the right places to standardize. And so this is a way of starting that conversation for us. Yeah, question?
Is that the last slide, by the way?
So, thank you. That was very interesting. So you talked about customers wanting to consolidate the Linux box with your router functionality. So what are the trade-offs that they're looking at? Because the consolidation can be done in the other direction too, right? They can take the Linux box and put the routing functionality in the Linux box and put whatever hardware, the special hardware that you need into the Linux box instead of you putting it in the router, because development environment in the Linux box is much better than development environment in your router. I'm guessing that. So what is the trade-off? Why do customers decide one way or the other?
Well, I'll give you a specific example is Redbox. I mean, if you think about the DVD kiosk, they have a very powerful embedded computer in there that's driving their display, driving all this stuff. And in the early days, they wanted to just put the routing in that, put the modem in that. And what they found is that to do that in a reliable way is outside of their skill set. And what was happening is things would hang. It would go offline and they'd have to roll a truck, and it was very expensive. So they came to us, and by the way, they will never consolidate their processing into our router. It's just too much. But to answer your question, what we're doing is providing multiple WAN connections that we can use analytics to determine performance characteristics of these WAN connections, latency, tying into the carrier provisioning systems to determine cost. We might start to see time of day pricing, latency, jitter, and then being able to make application-specific decisions about which WAN to use at what time. Retailers might want to, the holiday shopping season is upon us, and they might want to dial up their bandwidth and have multiple WANs in there to increase their availability, reliability through the holiday shopping season and maybe into January for the return season. So that's where our area of expertise over the last several years have been, is providing a very, very reliable WAN connection. We have products that have multiple LTE modems in. We have products that support Wi-Fi as WAN. We have all that we support all the wired options to really get that resiliency. There are going to be applications where they don't have that rich embedded computer, and they want like the pricing little SQL database that they wanted to put in there, and those are the applications that we'll start with. But obviously what you want to do in the gateway, and why we developed this sandbox, is it gives you the opportunity to do filter, exception-based management, really averages, min-max, try to make some intelligent decisions of what to send up and what not to. Yeah, hopefully that answered your question.
This is more of a general question. You mentioned we are going to swap our cards, so this is okay. Most of us, we are struggling in technology field, and this is one of the new field that we are trying to venture. People who are really into the ground came from real deal technology. You may say, okay, look at the fog computing as a hardware perspective, software perspective, new technology or hybrid, or look at the security side of it. It doesn't have to be answered right now, but if you guys have some inner sight that look at the direction and pay attention to in detail and look forward toward the light, that'll help us.
I appreciate those comments.
Okay, Rob, you want to talk about what you see in the marketplace?
Yeah, absolutely. Just 20, 30 slides. We'll knock them out real quick. I didn't bring any slides. Hope that's okay. So this is all very interesting stuff. No, that's too close. As I mentioned earlier, we take a pretty fundamentally different approach to this. The technology stuff is kind of cool. But we take a much more business-centric or economic-centric view of what's going on. And we've spent a long time in the last few years, which isn't a long time, but it feels like it. That's like 9 years in startup years, right? Working with large enterprises as they start to transition towards cloud strategy. And I've kind of broken this up into 3 phases. There's the cloud evaluation strategy, where companies say, can we go to the cloud? Should we go to the cloud? The cloud vendors are coming in going, I don't know what your IT guys are doing, but we can do it way better, way cheaper. And the IT guys are coming in saying, I don't know what the cloud guy's telling you, but we can do it way cheaper because we don't have to make a profit. And the CIO, CFO know that both people are lying to them, fundamentally, right, for the best of intentions. So you kind of go through this evaluation phase. And we've started to see over the last 18 months, large enterprises adopting cloud. And we've kind of talked about this. Everything we're building is cloud-centric. We're going cloud first. And you sort of get into the cloud euphoria stage. It kind of maps to the Gartner hype cycle where everything goes in the cloud. And it's interesting, you start to look at companies, and we have one company that we're working with that's moving a 27 petabyte database to the cloud, right? Because it's free. I mean, storage is free, right, in the cloud? Isn't it free? I thought it was free. But they're doing that, and that seemed like a really great idea because they were running on physical servers, right? I mean, I guess they're transitioning out of their HPUC servers. So they did that for technical reasons, but what they're starting to discover is that it's not free, and you start to get the bills, and you're starting to talk, multi-million-dollar per month bills from the cloud service providers. And that's interesting, but where it gets really problematic is now when somebody asks you, right? Think about medical data. You sell medical data, and a client calls and says, so I want the records on such and such a parameter, and then you execute a query. Well, to query that type of a database requires like 9 Amazon instances, and the dollar cost of that is non-trivial. So then you get out of this cloud euphoria stage when the CFO calls the CIO in and says, so let's talk about the Amazon bill. And you start to get into this cloud optimization or rationalization phase. And that's where I see a lot of applicability to everything that we're talking about here is, okay, great, we've moved it there, now what? That doesn't work either. It stems from, I think, a fundamental commercial problem. And that is large enterprises had rooms like this full of servers, and they could tell you what that room cost, right? What they couldn't tell you is what the dollar cost of each application in that room was. Right, and that was part of that cloud evaluation phase, is to try and figure out which of those applications, how do they work, what are the cost centers, and in traditional IT management, it becomes very difficult to tell the cost of the interconnects between the server racks and between the data collectors, because a lot of that stuff was local historically. So they really struggled with that, and that's sort of where we come in, is to start to say, well, what is the cost of running that application, right? When you take the compute, the network, the storage, and the devices, and then what does that data collection look like, and what does that look like as you extrapolate it into the future, right? If you grow at your current rate, if you grow at a 1.3x or a 1.5x or a 10x, what does that start to look like? And we're finally starting to see CIOs and CFOs take that approach, right? Let's stop. Okay, I've heard about the fact that it's going to be more agile, that it's going to cost less, that we're going to be able to do more. Like I've heard that with every technology shift. Let's talk about an actual quantification, an actual ROI on that. And we're starting to see a lot of applications where companies have skipped over that step, moved to the cloud, realize that the cloud is more expensive than what they were doing in the first place, and they're trying to rationalize that. And we do a lot of work in the financial services industry where you're aggregating enormous amounts of data and starting to do your calculations and make bets. So specifically what we're trying to do is to help organizations say, before you make the decision, let's not do a technical decision. Let's not do a vendor politics decision, right? Let's not do a I'm betting my bonus on this decision. Let's stop and do this. Let's quantify it. Let's put a real number on it in terms of dollar cost. And then let's figure out what types of architectures make sense going forward from a dollar cost perspective. And you're starting to see a lot of organizations realize that collecting every data point about everything doesn't make sense, right? That pushing everything into the database and doing all of the analytics on your multi-petabyte database in the cloud doesn't make sense financially. It doesn't make sense to stay where you are, but it doesn't make sense to do that either. And you're starting to see these organizations inherently explore these technologies like what we've been talking about, the edge applications. And even something as low tech as throwing a Linux server at the edge can be way more cost effective than centralizing things, right? And that's not even exploring any of the really cool stuff like leveraging the compute power in your huge routers and those kinds of technologies. But it's interesting, when companies started to virtualize, they virtualized 50 servers and ended up with 182 VMs, right? And we're seeing the same thing as you talk about network fragmentation, right? I've got 17 vendors and I want to fragment the network, and now I have 24 network links. Because once you start doing it, it becomes very easy, and you get that fragmentation, and they're losing view of their cost centers because they're fragmenting so badly. So it was interesting, you started with no insight because you didn't pay attention, and now you're ending up with no insight because it's fragmented so badly you have no way to track it. So it's interesting as we engage with the CFO, CIO, and the budget holders to try and figure out what this stuff is costing as it goes forward. And there are significant opportunities for savings, and there are significant opportunities for loss, and we're seeing both. But that's a really important thing to keep track of as you start to adopt these technologies. and you start to fragment some of these things, the cost centers become very obvious. And if you're not paying attention to that, it will absolutely sneak up on you. So that's sort of the areas that we've been looking at. How you do that, it can be a very complex exercise. It doesn't have to be. But if you're not paying attention to that from the start, it's something that will sneak up on you. Absolutely. So that's sort of summary of I guess, where 6Fusion, not to get into vendor pitch and show you demos and screenshots and things. Happy to do that if you're interested, but not the point of the conversation this morning.
Great. Thank you. Give him a round of applause. I had the visualization of dollar signs going and disappearing without the PowerPoint.
They come together and they get big, and then they, yeah.
Yeah. So, questions?
Yeah, I was listening to all the presentations, and I saw bandwidth is an issue, taking data locally, filtering it, taking it up to the cloud. Also capacity in the cloud, how much capacity you're actually using. And also security, to make sure nobody's hacking into your systems and things like this. But one thing is that kind of separates security from privacy, because I think that there may be some additional driver to move stuff out to the edge or even on premises, as you were saying, due to the privacy aspect of it. And do you separate privacy from security, or do you see it as the same thing? And I think that privacy may be a different driver for some companies.
Privacy is just one part of security. There are four, I have a talk about this, there are four parts to it. There's the reliability of the information, there's the content security, and then there's the content reliability. I mean, did you get the right information that you can guarantee that if you take a business action or some kind of event that needs to take place, either automated systems or a human being, that you got the right data. So privacy is just one part of it. It has some interesting impacts. I mean, I like the comments that were made over here. In our cloud solution, we have a combination of spillover into the cloud, but we have our own data centers with complete transparency in between, because the cost of operation in the cloud would be horrendous. We just wouldn't be able to do it. Getting the data into the cloud, processing it there would just be very high. But the aspect of privacy that you talk about drives us into certain solutions. There are political regulations that you have to take into account. Some of our customers in Germany, we can't have the data leave the country. So what do? Are we going to put in a data center in Germany? No, we're going to rely on a cloud-based solution in that country for that reason. Then we worry about the security aspects of that.
Yeah, I mean, we definitely treat it separately. In the old days, we used to have separate roadmaps for our hardware platform and our cloud-based management and a lot of the other components. And we finally realized that's not the way we needed to look at it. We needed to take a solution approach. And so now we have what we call solution layers that span both the on-prem and the cloud, and we have separate roadmaps for each layer. So there's connectivity is one of them, management is a second, privacy, private networking is a third, security is a fourth, analytics would be a fifth, and then extensibility. I missed one in there, there's seven, but that's the approach we take. And yes, they are very, very differently, and they're very different, and that's why you have to treat them separately. And again, because there's such a dependency now, or a fusion between the cloud and the on-prem, that's why we needed to do that.
I believe that there is an additional aspect of privacy. Actually, there are two aspects of privacy, right? One is making sure that some information that I care for belongs only to me. But then there are many situations in which it's valuable to share information across a wide population. Typical example is healthcare. Another one is precision agriculture, for instance. And in those situations, the problem with privacy becomes how can certain things be shared in a way that the participants want. Going back to healthcare is even more complicated, the question, because you want to have a very large database, can be anonymized, but by querying in certain ways with certain rare diseases, I mean, people can identify who is the person this is referring to. And that's why the concept of differential privacy was introduced. Anyway, we can discuss more further, but
Yeah,
I mean,
the
your question was well put. I mean,
the privacy is almost harder than the security, to be perfectly frank. Developers understand generally security technologies. The security technologies are generally industry standard, and they're generally portable across geographies and regions. Privacy is much more difficult. Every country is different, and it applies context in a way that generalized security does not. Makes it just, in terms of software development and, operating a SaaS platform much more tricky.
Yeah, we haven't talked about Europe, but one of the companies I recently interviewed was a company called Prism Skylabs, which does video surveillance. And what's interesting is what they do is they actually remove the human beings from the analytics that they provide. So you get a heat signature of human beings being in the spots, but you actually don't get any of the faces or the facial recognition. It's a very interesting approach. Gives some really good analytics, but you sit there and say, in the U.S., would people bother doing that? So it's very much an interesting mix of different countries' perspectives.
I would say as a result of Google's recent court settlement in Quebec, I would say no.
Okay. Last question.
Just don't want to sidetrack from the security. I am looking at something on a fog environment. The device itself can be self-healing. You have internet TV, suddenly you're watching something and it started downloading the firmware or flare version on it, upgrading it. The question is, when you give a device to somebody, a vendor, they bloat with craps that like iPhones, cell phones, all these things that are coming in the market, that you don't like them. So if you have a device, which is your edge device or in-house device, that can be part of your fog solution, and it is maintained by the vendor, not my grandfather who doesn't know how to do updates and unpatching, is there any solution can be looked at it down the road? A solution that is robust, not looking at marketing perspective, but the customer side of it.
Separating the devices from, what we do, the gateways that they're attached to, we spend enormous effort into that because our whole value proposition gets blown away the moment a customer rolls a truck. It's just that simple. I mean, the cost of a truck roll, the cost of 2 truck rolls all of a sudden becomes more than the cost of the hardware. So, I mean, the kinds of things, the reputation we've gotten is, quote, it just works. But under the hood, to get that reputation, we're doing, all the things that a lot of other equipment providers do. When you download firmware, you have A and the B, you roll back. We have learned over time that connecting to cellular networks is very tricky. And sometimes you need to go hunting for the right APN on your own. There's a lot of different things, a lot of different techniques that you can do to make it a little bit more self-resilient. But I don't think there's, we don't provide a platform necessarily for devices that attach to us to do that. We just really focus on making sure that network connection is up and running to give them the opportunity to do what they need to do with their devices.
One of the things that I think we all need to worry about is the cost of implementing security. You have to analyze, and again, there's so many, every application can be different. You have to look and see what is the significance of a breach, okay? If a particular device gets broken into or some event takes place where it's not impacting a lot of people, maybe impacting some data gathering, is it worth my doing something to prevent that from occurring or not? Simple, trivial little example. If I have a thermostat that's controlling in my house, that's measuring data, I have a Nest or something like that, if it gets broken into, do I really care? Is it going to impact anybody? Is there a fatality involved? Potentially yes, potentially no. You got to analyze that. On the other hand, we have some monitoring systems that are going into water distribution systems. If there's a breach of that device, then that's serious. I need to worry about implementing a security solution that is meaningful and avoids that breach from causing harm to a lot of people. You have to analyze it. There's no simple one shoe fits all, one size shoe fits all kind of solution here. You got to look. You got to see what's going on in every application and put security in upfront.
Nicola, any last thoughts?
Yes, for the security issue, you can manage the security on different level. We pay attention on the security, obviously, on the network. Okay, our goal is to ensure the connection between the machinery, because you know that we work on the industrial IoT, and your question is absolutely important. But in particular, I think your question has an impact on the residential application in particular, because people usually is not able to manage the security by ourselves, by themselves. Okay, but in industrial IoT, our goal is to ensure the physical security and to help our cloud provider partner to ensure the application security. Our choice is to use standard protocol in order to provide, in order to guarantee the maximum flexibility to our clients.